Hey everyone, so in this video we're going to start on the second method to solve systems of equations. Alright, and this one's called substitution. The idea of substitution is to take one equation and plug it in to the other. Alright, so let's look at example 4. So for example 4, we already have one of the variables solved for in one of the equations, and that's really important. Alright, in later examples we're not going to have one of the variables solved for yet, and we're going to have to do it ourselves, but that's always going to be the first step, is to get one of those variables solved for. So just over here to the side, solve for one variable in one equation. Okay. So x is already solved for, so here's what we do. Step 2, replace that variable in the other equation. Alright, so here's what I mean. If I said x equals 3, what would you normally do? Everywhere you see x, you would replace it with 3, right? It's kind of like the stuff we did at the beginning of the semester. If we know a number for a variable, we can just plug that number in for that variable. This is the same idea, except for instead of a number now, we're going to plug this entire expression into x. Alright, so we're going to have 3 times, that's where x is, so instead of x, we're just going to write 4 minus 2y. Then everything else is going to stay the same, so plus y equals negative 3. Alright, now here's the key thing to substitution. We had two variables and two equations, but as soon as we get here, we now just have one equation and one variable to solve for. Well, we know how to solve for one variable. That's just a linear equation at that point. So step 3 is going to be solve. So if we solve this, first thing we're going to need to do is just distribute the 3. So we're going to get 12 minus 6y plus y equals negative 3. We can combine the like terms. So we get 12 minus 5y equals negative 3. Subtract 12 from both sides. We got negative 5y equals negative 15. And lastly, divide by negative 5. And we get y equals 3. Alright, so we've solved it. We got y equals 3. But remember, we're not just looking for y. We're looking for x and y. So, how do we actually figure out what x is now? Well, if we know y, then we can just plug y back in to this top equation up here. Alright, so step 4, plug in and solve for your other variable. Alright, so we're plugging back in, we get x equals 4 minus 2, and then we see y, so instead of y, we're going to be putting 3, because we know y equals 3. So we have x equals 4 minus 6, x equals negative 2. All right, so now we have both of our variables. It's just time to write our answer. So to write your answer, remember it needs to be an ordered pair, x and y. So -2, comma 3, that is our answer. All right, so I'm going to go down just a bit for a second so I can give you that fifth step. Is just write your answer as an ordered pair. All right, so let's go ahead and take a look at example 5 now. So in this case, we don't have one of the variables solved for yet. Right? The good news is you can pick what variable you want to solve for. Right? There's not necessarily any wrong answers, but some of them are going to be a lot easier than others. So here's what I mean by that. If, say, we wanted to solve for this x, what would we have to do? We would have to subtract 3y from both sides. Then we would still have that 5 to deal with, so eventually we'd have to divide by 5, which would mean we would get fractions like -3/5 and 6/5. And unless you just really love fractions, that's going to be a bit messy. So let's look at a different variable. What about this y up here? Well, for that one, we have 3x plus y equals 2. And all we gotta do to solve is subtract 3x from both sides. So we get y equals -3x plus 2. No fractions. We got a variable solved for. Perfect. All right, so now remember, we need to plug this in to y in the other equation, right? So this, we're going to take it and plug it into the y in the equation that we did not just use. So we used the top equation, we want to plug it into the bottom equation. So we're going to get 5x, actually let me use a different color. (5x) plus 3 times y, which we now know is -3x plus 2, equals 6. Then it's just a matter of solving this equation now. So distribute, we get 5x minus 9x plus 6 equals 6. Next up, we can combine those like terms. So we get -4x plus 6 equals 6. Subtract 6 from both sides. We get -4x equals 0. And so then that gives us x equals 0 as our first one. All right, now I don't have as much room as y'all do on y'all's paper, so I'm going to have to erase these steps real quick. So if you need to pause the video if you haven't gotten those down yet, go for it. But I'm about to erase those off just so I can have more room for this problem real quick. All right, so now let's go ahead and finish off this problem. So we know x, which means in order to get y, we can just plug it back in. Well, the easiest spot to plug it back into would be right here, because we've already solved for y in that one. If we plug it back in anywhere else, then we're still going to have to solve for y again. So why not just plug it into the one that we already solved for y? So we're going to get y equals -3 times x, which you know is 0, plus 2. So that's y equals 0 plus 2, or y equals 2. So our answer is going to be x comma y, so 0, 2. And then we're done. All right, let's take a look at example 6 now. So in example 6, we actually already have y solved for. So we know we're just going to take that and plug it into the y in the second equation. So we get 6x plus 2 times y, which we know is negative 3x plus 8, equals 9. All right, distribute out. So 6x minus 6x plus 16 equals 9. Combine like terms, and 6x minus 6x actually just goes away. It's 0. So we're left with 16 equals 9. All right, now think back to whenever we're solving linear equations before. This 16 equals 9 is a false statement. All right, so if it's a false statement, then that means that we're just going to say no solution. All right. By the way, don't forget, you can still put the big O with the line through it. It still means no solution. So you're welcome to put that as well, either one. But make sure that you don't just put false, because the answer is no solution. Right? But in this case, we're done. There's nothing to plug back in. We don't have to go any further with this problem. That's it. All right, so example 7 now. All right, we don't have a variable to solve for, so we're just going to pick one to solve. All right. And normally, in my experience, if I ask students what they want to solve for, they pick this y right here. So I'm going to go with that one just because that's what most students tend to say. Again, don't forget, it does not matter which variable you solve for at the beginning. The other thing you could solve for is this x right here, and that would be perfectly fine as well. I wouldn't recommend trying to solve for either the other two just because they have numbers in front of them. It's going to be one extra step. So don't do extra work unless you have to. All right, so if we have 3x plus y equals 18, and we want to solve for y, it just means we're going to subtract 3x from both sides. So we get y equals negative 3x plus 18. And that is what we will put in for y in the other equation. So let's go ahead and do that. We're going to have x plus 1/3 times negative 3x plus 18 equals 6. We're going to distribute out the 1/3. Remember, if we're multiplying by 1/3, it really just means we're dividing by 3. All right, so this is going to be x. Negative 3x divided by 3 would be minus 1x. 18 divided by 3 would be plus 6 equals 6. We combine like terms, and again, x minus x is going to cancel out. So we get 6 equals 6. In this case, that is a true statement, because 6 does equal 6. Now, remember, we're talking about systems now, so the answer is not just all real numbers like it was before for just linear equations. Our new version of all real numbers was infinitely many solutions. and then we're done. Alright guys, so that is substitution, and we still have one last method to go. Alright, so there's going to be one more part for these notes, one last one. So right about now you should see that card pop up that you can click on to go straight to part 3, and I will see you in that video.